Welcome, everybody, back to the Beyond the Big Bang podcast. We've heard it all before. COVID is fake, vaccines give you autism, genetically modified foods are bad for you, and of course, the Earth is flat. In recent years, there has been a growing mistrust of science. And what's behind this? What can we do about it? You heard us talk about it last week, and today's the week we have a very special guest. I think he's often referred to as the king of flat Earth himself. He was a of the documentary Behind the Curve. He's been a keynote speaker at several Flat Earth conferences, and he has almost 19 million views on his YouTube channel. Mark Sargent, thank you very much for being here.
Thank you very much for inviting me. It is a pleasure. And am I speaking mostly to a Canadian audience?
Yes.
Yes, we're both Canadian.
So up there in Canada, I've heard good things.
Up there.
Up there. Oof. Careful.
Well, you know what I mean. I live in Washington. I live in Seattle, so fine.
So we're up, I guess.
Up north there, north in the yeah.
In the
I guess
center.
we should probably introduce ourselves, shouldn't we, Hannah? So
Sure,
for
yeah.
our readers that are unaware, I study physics at the University of Toronto. I have an undergraduate degree in physics, and I'm now doing a PhD in computational fluid dynamics.
I'm Hannah. I'm also a graduate student in physics. I study cosmology. And for those of you who are joining us again, you might notice that our usual other two scientists are not joining us today. Gunjan and Trevor decided not to join the conversation today. They didn't feel like it was something that they wanted to speak about. And, you know, we respect their decision to not be here. And we're going to have a great chat.
That actually circles back to one of your first questions is, do you talk to scientists a lot, or did they sort of push you away? The other two people in question, what is their specialty?
Trevor has a PhD in numerical relativity in astrophysics, and he's
never going to talk to me. No.
And he now works at a quantum computing company.
Yep, even worse.
So he's
yep. And the other guy?
And Gunjan has also a PhD in computational astrophysics, and he now works as a machine learning specialist.
Yeah, it's again, not to drag this one out, but that's the reason why we have so few, why we pick up as many people as we do, and why science has a tough time going against us, because to most people in that community, it is utterly, and it was talked about in the documentary, it is utterly beneath them. So why would we talk about it? It's absolutely silly. It's ridiculous. It's stupid. Why would we even address it? And it's like, fine, we will just keep doing what we're doing by attrition. And to your point, by the way, your show introduction, you're saying, no, how can you stop or stem the tide of the anti-scientism thing? By addressing it, by having a lot more people like you trying, getting out there and doing that. Your friends, and I'm not trying to pick on them, not being here. Yeah, that's part of the problem. We created a model of the known universe that is easier to explain than the heliocentric model. And in doing so, remember, the general public, whether you agree with it or not, they like easy. They always have. You guys are in the top whatever 1% of the elite of the academic. And the general population, the mouth-breathing troglodytes out there, you know who they are? They make up the bulk of the population. And so if we show them this with all sorts of explanations on how it works, and it makes sense to them, what do you think they're going to go with? They're going to, I'll make it really quick. The heliocentric model takes what? Geometry and trigonometry and calculus and quantum mechanics and blah, 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 blah. This, maybe some advanced algebra, maybe a touch of geometry. That's about it, especially if it's enclosed. And that makes it much, much easier to understand.
Well, I mean, do you think so as a physicist, I obviously believe that there's a very big place for mathematics in physics and when we're understanding our universe. Do you think that there is a place for math in a anthropocentric model?
The math you're talking about, it doesn't have nearly the prominence that it does now. No, not even close. Again, your average person, it, it, I, your audience is probably much more academic than the people that I usually talk to. But the average person that gets through, we'll just say high school, not even university, I mean, we barely teach them enough to get by. They know nothing really much about chemistry or engineering or biology or physics or any of that stuff. There's a reason
So
why the chess
that's
club
an
and the math.
interesting question to me. I
Yeah.
mean, did you ever have the intention of wanting to go to college, or do you know of any flat earthers that wanted to go to university?
Oh no, quite a few of them did. I did. I was thrown out my junior year for manufacturing explosives on campus,
Huh.
which was a
I mean, that
whole.
sounds like a scientist to me.
Yeah.
Well, science. I've got such a weird paradox in my head when it comes to science. Neil deGrasse Tyson,
Hmm.
the Lord God of media scientists, and only one of three media scientists in the entire world, in the English-speaking world anyway. He said one of the most arrogant things I've ever heard in my life, which is science is true whether or not you believe in it. And I question that a lot. And what I try to tell people is don't take science at face value. Science is wrong a lot on a lot of things, but they never apologize for it. They just restate things. They just
Well,
reprioritize
I
things.
mean, I think we should be careful. Are we talking about, is science wrong, or is any particular scientific theory wrong?
There you go.
Because science is a process that corrects itself.
You're absolutely right. I forgot the audience I'm talking to here. Yes, there are certain aspects. So, okay, let's drill down that for a second, which is you want to tell me what the boiling temperature of water is at sea level. Great, fine. I can go get a pot and a stove and a thermometer, and I can test that myself and figure out what altitude we're at. You want to tell me what the core of the Earth looks like? Oh, no. You can't, not even close. I mean, the core of the Earth is supposedly 4,000 miles down from where you are now. The deepest hole ever drilled, what is it? Is it 2,000 miles? 1,000? 100? 10? It's 8 miles. That's the deepest hole ever drilled. And in fact, in the fine print, and you can wiki this all day long, they'll tell you, it's like, oh yeah, we have no idea what's down there. We're just extrapolating from volcanoes. So, okay, why are you
Well, I mean,
showing me
not
these?
just volcanoes, to be fair. Not just volcanoes. We do have seismic data that tells us a good chunk about what's underneath the core, the surface of the Earth. I mean,
So those bands, those perfect 1,000-mile thick bands of red and orange and yellow and white, you know exactly what those are. No, you don't. No, you don't. And even if you could, why are you showing me the cross sections of Neptune and Jupiter and Saturn, places we supposedly haven't even sent probes to?
Well,
How are you
because
showing me this?
we have methods of, we don't have to go to the sun and take a scoop out of the sun to know what the sun is made of. Like,
Yeah, you
there
do.
are different that
don't
you do
actually.
not. You actually do not, because of this process called spectroscopy, where the atoms themselves, specific atoms, have different signatures in a spectrum. They release particular types of light, and it's unique to each atom, or a molecule. There are transitions that release light, which is unique to all of these atoms and molecules. And so if we see those spectra, then we know what the sun is made of.
and by the way, Mark,
And
this is an experiment that you can do yourself at
yeah,
home.
you can do this experiment at
You
home.
just need a
Uh-huh.
spectrometer.
Yeah.
Right. So sticks and shadows argument. The sun does work if the sun is 93 million miles away, and I don't know if you guys use kilometers, however many kilometers wide it is, 400, 800,000 kilometers. But the sticks and shadows argument also works if the light source is very close and very small. And you can do this with a shadow and a pencil all day long. So again, if you want to recite textbooks on what you think the sun is, and by the way, when you say you know what the sun is without actually going there and sending a probe and taking a scoop out of it, I would disagree. There's
So
not
I guess
much
this comes down to the fact that you are like a hard empiricist. Like, you need to see it with your own eyes. Would that be fair to say?
Yep, absolutely.
But I guess
And science is like that sometimes too. That's where there's kind of, and again, I'm not trying to be insulting here. I know, your background, which is the hypocrisy of it is that, like, for example, unless there's certain things when science doesn't see it for themselves, they absolutely say it's a myth. It's absolutely imaginary. You know, the giant panda, let's do cryptozoology for a second. Giant panda was an utter myth. The giant anaconda, the giant squid, you'd still, guys, the science community would still think it was a myth, except that you found remnants inside the bellies of sperm whales.
But I guess the point is that science it's a myth until evidence, right? So until it's not that we're saying it's never possible, but we're saying until evidence is provided, we're not going to believe in something that hasn't been shown. And I know what you're going to say, that there are so many things we believe in that we have not shown with evidence. For example, like the evidence that you would like, perhaps. Like you want us to actually cut through the earth and see a cross section. And that would be the type of evidence that you would take to be true. But I guess what's different about science is that we have this framework, which maybe we can talk about, where there are predictions other than the blatant cross-section, look at the cross-section. There are processes that would result from the structure underneath. And if you detect the structure, if you detect, these processes, then you can infer the structure from it.
Got it.
I'll give you another example for this. So leaving science aside, for example,
sure.
I think if you're going to stick to empiricism and stick to that for the rest of your life, I think that's an inconsistent view to have, because you can't go through life without at some point trusting the process from someone else. So for example, when you go to the grocery store, well, not like religion. So when you go to the grocery store and you buy canned food, do you trust that what you're reading on the label is what's inside the can? I mean, yes, you trust it, because how do you trust that it's going to be edible? You trust that there are regulations in place, that people are doing this properly. There's a system, there's a method, and you trust that. You don't have to see what's inside the can before you buy it. So why can it not be the same with science?
To your point, though, eventually you do open the can and you do eat it. But the first time you're opening that can, you're looking at it like, I don't know. If you want to go down that road, fine. Let's do your cosmology thing. Do you believe in dark matter?
I mean, dark matter in the sense of what?
Do you buy into the theory? I mean, there are people octaves above you that are spending their entire lives convinced that dark matter is a thing, and they are going to go to their grave trying to prove it.
Right.
Well,
but in the meantime, they're telling people, they're telling mainstream media, it's like, oh no, dark matter, that's what makes up. I mean, they're stating it like an absolute fact.
Well, we don't know what dark matter is per se, and Hannah can speak to this a lot more than I can. We don't know what it is per se, but we have evidence that it exists, and we have evidence that is there. We can see it through our evidence. So,
right. Like when we measure the content of the universe, we measure the content in several different ways. And what happens to be going on is that what we see with light is not what matches certain other data. And for the other data to make sense, there needs to be matter there, or something that is behaving like matter. So I guess dark matter doesn't really refer to a thing in particular the way the core of the earth is something that we refer to as a thing in particular. But it is some missing piece that we know has to exist. And that's what people are studying.
That's the point. It has to. You don't have absolute proof, but you're saying it has to exist.
We do
it
have
has to
proof,
exist because
though,
we see
because
it.
of
we have
the proof
that it's there.
We have proof that
you guys both
something
believe
is
in
there.
it. You believe that dark matter is absolutely a thing, and one day somebody's gonna come down the pipe and lay out exactly what dark matter is.
So one day someone will explain what the thing that is producing the anomalies in our data is. That's what I will say.
All right. How about this one? Gravity, because that, when we're dealing with people, not you, octaves below you, that is the answer to almost every question there is, even though every mainstream scientist we have talked to, full-blown scientists, said, we can't tell you what gravity is. We can only tell you what it does. We can only tell you the symptoms of it.
That's not necessarily
I don't think that's true.
Really, that's Neil Tyson's words. I could give you a recording like right now.
I can see him saying
that this many times. He is your Lord and God.
I'll tell you a little secret. So among the scientist community, Neil deGrasse Tyson, we respect him and we We care about him a lot because he does a lot for science education, but we don't see him as a god, and he certainly does say things that are questionable. So he does not represent
he is
all
your
scientists.
spokesperson. He is the press secretary of science, along with
According
Brian
to who?
Cox.
Who assigned him? I didn't let him be that. I didn't give him permission.
Doesn't
to
really
speak for
matter.
me.
The mainstream media did. There are
Right.
3 people out there that they talk to on a regular basis. Neil deGrasse Tyson, far and above.
Mhm.
Even though, believe me, I understand your opinion on this. He is a cross between Sinbad and Bill Cosby. He's great on stage, meaning his stage performance, he could sell. He's a salesman. He could sell anything. The fact that he's in astrophysics, weird. I mean, I think he could do better doing other things. Brian Cox out of England, Michio Kaku. That's really it. And then for whatever reason, they bring out Bill Nye. And I would think you guys have an opinion on him, considering he's an actor out of Seattle and he's got his bachelor's in mechanical, and then went into acting and abandoned, the whole mechanical engineering thing almost immediately. Got syndicated by Disney, and now he's on CNN talking about the Mars rover.
So if we're coming back to your original question, though, you were asking about gravity. So what is your question about gravity?
What do you think it is? If everyone that goes on TV says that they can't tell you what gravity is, they don't tell you what it does. Your response to that is
we know what it is. That's the thing. And the thing is, I almost feel as though, and I have this problem with mainstream media, which I think is why we decided that we would kind of start our own science podcast and whatnot, because there's a lot more science that the mainstream media is not talking about. And one of those things are kind of like the nitty gritty of what's going on underneath all of the, I guess, surface level popular science, I would say.
Is the nitty gritty what you may or may not introduce here?
Yes. So what it is that gravity is nothing more than matter deforming this space-time. It's not an attractive force that you learn about in high school. It's not like a little rope to one ball tugging on the other and the other ball tugging on the other with equal and opposite force that's proportional to their masses. It's not that. It is literally mass deforming space, and then just like a hill, things roll down hills. So when matter comes close to something, when a small ball comes close to a heavy ball that's deforming space and making it into a hill, it'll roll down and be attracted, just like gravity. So in the globe model, I guess I'll say, is, the Earth is much heavier than we are, so it's deforming the space-time that we are in, and we've fallen into that well.
So to put slightly different words on it, because we might get called out. I feel we might get called out for trying to explain gravity with gravity by the hill analogy. To put it in different words, what Hannah's saying is exactly that. It's that so a massive object will deform space-time, and we have precise mathematical descriptions of how this works. We understand this well, how matter can deform space-time, and then objects simply move in straight lines through a deformed space. And if you move through a straight line in deformed space, that appears as gravity.
And by straight lines, it's I guess we should be clear that straight lines on a curved surface, or as Alex said, a deformed space, don't look like straight lines that you and I would draw on a piece of paper. And by straight line, in physics terms, what a straight line means is the path of shortest distance. So sometimes when the space is curved, that distance, the shortest distance, would look from a bird's eye view as a curved line, but really it just means the path of shortest distance. So that's what gravity is. That's the thing, is scientists know very well what gravity is. I really don't know why popular scientists don't want to say that. Feel the masses need or can know.
Because the textbook answer takes too long, and it's still sort of ethereal in nature when you're trying to, I know this is audio only, but it's tough to remember. You gotta remember who's out there, and I can't stress this enough. The average person on the street wouldn't have understood any of that. They would have absolutely lost it. In fact, they would have come back at you. In fact, even maybe a little bit smarter person would have said, can you show me something in a lab that reproduces this? Can you reproduce gravity in a lab?
You can.
We can.
Really? Because you're the first person I have heard in 6 years say that.
Well,
you
we
can.
detect it with things
No,
like...
do not detect
No,
it.
you can see it
show it?
directly. You can show it directly with the Cavendish experiment. And it takes
Yes, the Cavendish experiment.
you can and people have done this, and I mean, I'm sure that you have an alternative explanation, but
Oh, you want me to give it
or
to
do
you?
or do you? I'm not sure. I just
I think the
assumed that you
Cavendish
would.
experiment is unproven. I think it is a failed experiment. Plain and
Why?
simple. Because the Cavendish experiment wouldn't work the way you were hoping it would work, because you are supposedly on if for the Cavendish experiment to work, you're supposedly on a ball that has its own gravitational force anyway. So how would it work? Exactly.
But we see it work.
But not
show,
only
show me video on it when after this is over. I
Sure.
want to see it.
Perfect.
Okay.
I want to see it. I will show it to the community, and if they're convinced, we'll quit this whole thing tomorrow, which I would be unlikely.
Fantastic.
Yeah.
You know what I
guess we'll
realized,
talk
Mark?
about that more later.
We
but-
haven't even gotten into what are your views exactly.
Oh yeah. I'm sorry. Let's do it real quick. The short version: you are not on a tiny little rock covered in a little bit of water and a little bit of smoke flying through the impossible vacuum endless universe at velocities that are mind-boggling. You are, and you're not an accident. You are sitting, I don't know, on a shelf. You're not an asteroid flying in space. You're not this, you're not Asgard. You're basically in a snow globe, a planetarium, a terrarium. You are in a building with walls and a floor and a ceiling, no different than a Hollywood backlot. And it is so big and engineered so well that even our best and brightest didn't figure it out till almost 1960. And when they did, because we didn't, I mean, the internal combustion engine, without that, we were never going to discover it.
Sorry for interrupting, but this was, so just to clarify, this was engineered before our time. We were put here.
Yeah, we had nothing to do with this. In
Okay.
fact, I mean, I'll steal a line out of Contact with Jodie Foster. When she asked them, when she finally got to the end, and she goes, did you build this? He goes, we didn't build this. We don't know who did. One of the most humbling things I've ever heard in movies. Thank God they said it. But no, we didn't engineer this. This was engineered by an older civilization, much more powerful than ourselves, or some sort of deity, but then you're kind of splitting hairs. And what's outside of it? It's not space. In fact, we don't know what's outside of it. We've tried to bust through it for 4 years straight. The United States and Soviet Union tried to nuke the hell out of it. Couldn't get anywhere. And they kept it a secret. And why would they keep it a secret? Are you kidding? Civilization was already in place. The foundations were already laid. It's not what they stood to gain, is what they stood to lose. Academics would be just thrashed. Economics, world markets have to be suspended.
We might be out of a job, right, Hannah?
But I mean, why would that be the case? I guess.
Why not?
But why?
No. If you're going to go down that road, I mean, seriously, the only difference between you and me is that you think the Big Bang was an accident, and I think it was deliberate. How's that? You want to oversimplify?
You believe in the Big Bang?
Do I believe in the Big Bang? Sure. But I believe that it was deliberate and it was made much, much smaller. Meaning things came into existence, but you didn't need a universe to do it.
But I guess I mean, one thing that's troubling to me is that, science can explain a lot of things, like the motion of the stars, stuff that goes on, in, I guess, what you call the dome, or beyond the dome, I guess.
Why would it be beyond the dome?
Or I guess there is stuff beyond the dome, presumably. I guess, why would you choose to believe in a theory that can explain so little when...
Why would you need to explain more? Meaning, let's do this. If you go into a planetarium, and I know that dates me, if you go into a planetarium and you look up in the sky and you see Jupiter, right? And it's like, wow, look, it's Jupiter. And there's some moons of Jupiter, depending on which one it is. And you go, yep, there it is. Looks spherical. Yep, it does. Can you land on it? No. Why not? Well, because it's just lights on a ceiling. who's to say when you walk outside, you're just not looking at a much better light show? In fact, let's take it one step further. Let's say you took somebody from another country that really didn't have any technology. I'm not going to pick on countries in South America or something but it's like an Amish person that's never seen technology. And you bring them into a planetarium. Would it not freak them out to no end? And trying to explain it to them, they'd want probably a simple explanation. I know that, look, science tries
the firmament is some sort of like a dome that the stars rotate or something, or it's just a big projector that
could be either, to be honest. I mean, could be front projection, could be rear projection, could be a 1 million K HD system up there. I don't know, but it is so far above us in terms of engineering.
Here's something that I always wondered, though, because I've heard this argument before about having some sort of projection or rotating firmament, whatever.
Sure.
That doesn't explain the motion of the stars.
Why not?
Because in the northern hemisphere, you can see stars. I don't know if it's clockwise or counterclockwise, but you can see
when you
them
go down
clearly
Australia, it's
direction.
counterclockwise.
It's counterclockwise. In the equator, it's one direction. You can't explain that on
how. Do you not? Oh, it's right. You guys don't play games. Do you guys play any games at all? Any simulations? It's called instancing.
Sure.
If you know software at all, and I do, it's something we've done for 20 years, which is called instancing, which means you can, the easy version would be you're in Australia and I'm in North America and you see the belt of Orion and I see the belt of Orion and you say, hey, the middle star is blue and I say the middle star is red. Who's right? And it's of course turned the wrong way.
So everyone has their own individual perception of reality.
So it doesn't have to be necessarily, it doesn't have to be necessarily individual, but it could be regional. I mean, that's how we trick people in the virtual things we create now.
So the deception is going on to some extent. It's going on inside our brains then.
Some of it, sure. Why this shouldn't be too much of a stretch for you guys. I mean, you guys were the guys that came up with the whole virtual reality concept.
But I guess my concern is now if the Earth is flat like this.
Yes.
And let's say there's someone kind of in the middle looking up.
Yep.
Should they not be able to see kind of all, if they look in a 360 degrees, should they not be able to see the same, at least an overlapping region that someone at the very edge could see?
Depends how it's laid out. Again, if you're instancing the sky, it's something in software we call the skybox system, because it's not actually a dome, it's a square, because computers can't do circles, not really. You can tailor it for just about anything you want. And I'm not trying to oversimplify the universe necessarily. What I'm trying to say is that science has a nagging tendency to overdo it, to overanalyze everything and make it way bigger than it actually is, which I don't think.
Could it?
So I think what anything, science has a tendency to try and find flaws in its own arguments. So I'll give you another paradox here.
You want to go down this road?
See if you can give me this one. Riddle me this, Mark.
Yeah.
So if I have a certain instance of the sky, okay, I see things a certain way, and you're saying that someone in Australia is a different instance, okay?
Yep.
So then if I travel and I'm continuously looking at the sky the entire time that I travel down to Australia, okay, so I never take my eyes off the sky. By the time that I get to Australia, my friend in Australia is looking at the same patch of sky that I'm looking at now. Are you telling me that we're going to see two completely different things?
Dun, dun, dun. Possibly. Yeah. Very, very possible. Why not? I mean, first, it's never happened, and that's one of the most original things I've heard in probably 6 months. So pat yourself on the back for that. It's never been tried. It's never been, but theoretically, yes. Yeah. I mean, it's something that we do now. And let me preface this, so that I don't completely alienate the people that are listening to this. If I believe that it is flat and it is enclosed, there is a high degree of probability that it's digital, that it's virtual, that it's some sort of construct. I mean, come on, the double slit experiment, especially the most recent ones back in the early 2000s, just scream virtual. Absolutely scream it. I mean, because what we were
doing, as in like a glitch or something like that, or
not even a glitch. No. It's resource conservation. So what we do,
I see.
What we do in the software world, when we try to save resources, the easiest way is if you're not looking at it, you don't render it that well. It's called flashlight graphics. And so why is it happening here? Why is that happening in this world? Why is it happening? I know I'm ripping off the 13th Floor, which was based off of World on a Wire, which was based on a 1960s book, but they've been thinking about this for a long time, and it shouldn't be there, but it is. That, and of course, look up, if you want to have some fun, look up neuroscience versus free will. Your guys' stuff, not mine. Where apparently they can because I know you guys hate the concept of predestination, where you can actually register the human brain waves making a decision 8 seconds before they actually make the decision. Should be impossible unless you're talking about something that's potentially pre-recorded.
Well, it's not necessarily impossible. I mean, they have hypotheses for why that is, or why humans would appear to themselves to have free will, and some people have hypothesized, I mean, this is tangential, but some people have hypothesized that the human brain, it's almost an illusion that we have free will, and it was an evolutionary advantage to think that you had the ability to kind of like control your own future and control where you get your resources. Like there are people who are coming up with, scientific hypotheses about why the brain would either trick you into thinking you had free will even if you don't. And in some senses, certain scientists are physicalists, like they think that everything trickles down to like the nitty gritty of like, if a particle moves here in your brain, then you have this thought, like physics like gives rise to your reality instead of, your reality emerging from some other, from like a soul or something like that.
Oh, well, heck, I mean, not to delve into something sidetracked, but the electrochemical stuff where this goes a long time before you guys, where people would think about shooting free throws, and they would actually do better. Right. And then we were making the connection to veterans. Most of the earlier ones were like Vietnam vets, and like they said, they could hear helicopters. And then all of a sudden they figured, okay, wait a minute, electrochemically, there's almost no difference between realizing something right now and a very, very strong memory. Electrochemically, it was almost no difference at all. And so then it leads into, okay, how tough would it be to plug that in? So, sorry. Circle back. Sometimes I don't say this very often, but it's not even sometimes that I believe in a virtual reality. I believe in the virtual movie, that everything was pre-done beforehand, like pre-record. All decisions were made before you get in there, because that is the most efficient way of doing it. No different than the people that go out there and record video games and put them on YouTube, and that's what you're watching. But you're not watching an actual game happening. You're just watching a movie of a game happening.
So, I do have, I have science friends of mine that do believe that, we live in a simulation, and there is certainly large discussion to be had there. But I think there's nuance to it, because it's not just a simulation where we have quantum effects being a result of rendering errors. That's not true, because, for example, you were talking about the double slit experiment, that, the weird quantum effects that we see are because, we don't have certain resolution. Well, if that were the case, I work with numerics every day, I can tell you that, when you have a rounding error of some sort, then it's a random error. It's some sort of a random process. You would expect a uniform, a Gaussian distribution, whatever it is. But with the probabilities I end up observing with quantum mechanics, they follow the mathematics and quantum mechanics that we understand to the tooth and nail. I mean, we understand very well where these probabilities are coming from. It's not just a rounding error that you'd expect from a glitch. So while, yes, the idea of a simulation has certain merits, I don't think it can be used to explain the weird physics that we see, and that physics is a lie,
Yeah, I hear you. I mean, for me, by the way, I do not think that the double slit experiment is any sort of glitch. I think it's very deliberate, because, and there's papers on this, people have said it doesn't matter how much computing power you have, you're always going to follow the rule of resource conservation, just because you can. It's like, why build it? Why build everything down? Why take the resolution all the way down to the granular level if you don't have to? And I was like, okay. Anyway, sorry. I know you guys have questions. Go. What else you got?
Well, I have something. Shifting topics a little bit.
Sure.
What testable prediction of flat Earth theory? So, yeah, what testable prediction of flat Earth theory could I propose to you that if I prove flat Earth theory wrong, what would change your mind?
That is, by the way, the first time anyone has ever used those words. When choosing, it's like normally, again, remember who I usually talk to. It's like, what would I have to do to make you quit flat Earth tomorrow? It's a good question. One of two things. First one would be difficult to do because the cost or the permission involved, and that is get any sort of decent camera, strap it onto any capsule of anything, point it down at the ground, don't point it up, and let this baby, and something that's going to leave orbit.
Well, we don't believe the images from SpaceX or NASA, or we don't believe any of those, do we? Or Virgin or Boeing, all of their flights.
When you say we, the royal we, like, do I believe in it or you believe in it?
Sorry, you.
Oh,
you don't believe any of those images, do you?
Oh, I will. You know what? Just for that, let me see. Do we have a chat box here? Yes, we do. Just for an example. Okay, so you got a camera, you point it down at the ground, something's going to leave orbit, take off, and eventually, don't hit edit, don't hit pause, and the Earth should start forming into a globe, and that it's never happened in the history of space travel. It's statistically extremely unlikely that would be the case. As a matter of fact, why Elon Musk didn't do it with the Roadster in space when he had 3 HD cameras on it with perfect transmission and supposedly was going to Mars. Oh, we're going to slingshot around the sun and head towards Mars, but we're going to cut transmission before we start any of that. Whatever. That'd be the first one. Give me a 4K. Give us 4K footage of any of that happening. It's never ever happened. You want something on the ground, because I had scientists say, well, it's going to be tough to do because you're going to have to get permission from Google X or Blue Horizon or any of the other crap, Virgin Galactic. The one on the ground that I put out there for 4 years now, and nobody's come up with, is the Spacesuit Challenge, which is, and in fact, I did a video on it called For Want of a Nail, if you remember the old story about, it's kind of like the Stitch in Time thing, where the nail and the horse of the shoe, and then the horse was lost, and the battle was lost, and the war was lost. The spacesuit doesn't act like it should, not according to thermodynamics. Thermodynamics, pressure cannot exist in non-pressure without some sort of barrier. And if it's a soft barrier, that baby's going to go rigid in a second. That spacesuit should blow up like a parade float and burst really, really fast. And so my question
Sorry, I don't understand. You think so this is in the picture you sent, right? If we're on the moon.
Oh yeah, no, that picture. No, well, we'll get that picture in a second.
Okay, so but if you're in space and you're in a spacesuit,
you're in a spacesuit and you're in a vacuum.
Okay.
And you can watch any sort of videos you want online about anything. Because we're humans and we're dumb, we put everything in a vacuum chamber at some point and destroy it. So why doesn't a spacesuit become a basketball? Why doesn't it happen? And people say, well, it's layers. It's some sort of layers. And no, my winter coat has layers. It's the only thing that stops it. Winter is the cold. Tell me what magical thing is in that backpack, that self-contained backpack, that stops the vacuum of space from bursting that suit. And at the very least, would make it unbelievably rigid. And yet there's full articulation points, move your arms and legs. They can manipulate complex electronics. That my challenge is, loan me any spacesuit, put me in a university vacuum chamber. It'd be nice if somebody else went in with me, but if I had to go in by myself, that's fine, and tell me how it works. And even if you can convince me that in 2021, we've got that tech, what tech did we have in 1969?
So, I mean, I'll have to get back to you on the specifics of this, because I don't know, I'm not too familiar with the engineering of the spacesuits, but we do have certain materials that are flexible and incredibly strong.
Nope. No. In fact, I'll even take it one step further. You can look this up, do some research offline on this. The early suits that they first devised for the space program were metal and plastic, because of the law involved, right? They're like, yeah,
Okay.
we got to do something about this vacuum. But they were so unbelievably clunky. They looked like B-movie science fiction robots. And they're going, yeah, we're never going to be able to get inside or outside of a space capsule. And then somebody made the brilliant decision, again, because it was going to be faked. And I'm sorry if I offend people here. And it's going to be faked. It's like, let's do soft suits. Yeah, let's do soft suits, because no one knows anything about physics at all. The general public won't even register. And they didn't. And it was brilliant. It was perfect. It worked. It was flawless, along with everything else in that photograph, by the way.
But I don't see the issue here. What's the issue with having certain materials that have very strong tensile strength but are still flexible? I mean, we have those materials.
You can't have both, not in a vacuum. It
Yes,
cannot
you
be done. No, you
okay.
can't be flexible and rigid at the same time. It can't be done. There's nothing you can do. And my
It
point
doesn't have to be rigid. It can be flexible and have
with
tensile
what
strength.
muscles are you? Remember, the suit will blow up to whatever the shape is. It is. Every time you try to bend your arm, you're fighting the suit at that point. And they're not fighting anything at all. They were breathing heavy on the moon. But look at that picture, by the way. The longer you stare at it, the worse it gets. And again, I'll give you the real simple stuff, right?
The picture.
Forget about no stars in the background. I don't care. People are going to say exposure settings. I don't care about that, even though there's no stars in any photograph ever. 3 quick things. One would be if there is a light source that's 93 million miles away and there's only one light source, all the shadows run what? Parallel. Thank you. Oh, that's a problem. None of those
Sure, I mean,
shadows.
this is taken with a very wide-angle lens.
No, but when that's going to explain the shadows running perpendicular, they're going to intersect. Those shadows are all going to intersect. Fine. If you don't want to look at that one, by the way, no one's been able to answer that ever. Most people.
I mean, what if? I mean, hold on. Like,
there's
for
nothing
example,
you can do. That only happens if there's a light source 30 yards behind them.
What if this was like a, on your iPhone, you take a panorama and it stitches things that were, stitches things together at inconsistent angles. Like, are you sure? Like, how are we sure that this
straight off the NASA website, date and time stamped?
Sure, but we don't know if this was multiple images stitched or not.
If you take a wide-angle lens or if you do a panorama, then
even
this is
if
what
you
you're going to
did
see.
a panorama, those shadows are not going to be like that.
Okay, I'll give you another idea though. If, as you say, there should be a light source 30 meters behind or whatever, then the shadows would be going outwards, not inwards.
Not necessarily.
Why not? That's how shadows work.
Look, studio lighting you can do just about anything you want.
But I only see one shadow. But in this case,
the shadows will not. Doesn't matter. Do not go that way and say they're going to go out instead of in. The point is they should be running parallel. Doesn't matter if you want to say they're going out, that's fine. But either way, they're not running parallel. Second point. Ready? You see all the footprints. This is a great image, by the way. All these footprints, by the way, perfect uniform 3-inch, 4-inch ash around everything. I always thought that was kind of strange because no one was in a shovel. It's like, what's underneath that ash? How deep is the ash? Is it only 3 or 4 inches? Perfect, which is what you would do in a studio. Footprints everywhere, right? Can't miss them.
Okay.
What's missing in that shot? See it? Anyone? How about the blast crater, the splay pattern? That's a 10,000 pounds of thrust American engine under that thing. There should be a huge splay pattern.
There's no wind.
There shouldn't be any ash underneath that thing at all.
There's no wind, though. You wouldn't.
No, it doesn't matter with the wind. The thrust itself would have kicked out the ash. Don't give me this wind thing. Come on, man. The thrust would have knocked the ash away. It would be nothing but rock underneath.
Not necessarily, because the reason that thrust knocks things away is because you have an air current that's pushing things out of the way. If you just have thrust going downwards in a vacuum, then it's just going to be a straight downward force, and then the sand is going to be propelled downwards and not move. It's the air that needs to get out of the way, and therefore pushes things sideways. If you're going to
go in that direction, then I would counter with this, which is my point.
Okay.
When we're swimming, our arms push against what? Water. When we're walking, our feet push against the ground. When a plane is in the air, it pushes against the air because what we're breathing in here is just this soup, nitrogen and oxygen. When you're in a vacuum, what's it pushing off of?
It's not pushing momentum off of anything. What it's doing is it's propelling. No, it doesn't have to. The thing is, No, it doesn't have to, because what it's doing is it's burning fuel. The fuel is being shot out one direction, and by Newton's third law, you then get propelled in the other direction, because equal and opposite force.
You can do this experiment yourself if you sit in a rolling chair. If I right now in my chair, if I have a bowling
you're
ball
not in a vacuum.
and I throw a
Not
bowling
in a
ball
vacuum.
forward, you don't need to be in a vacuum.
Even more in a vacuum. You notice these
it's
effects
even
even
more
more
so.
so in a vacuum.
I'm sitting
Offline,
in a chair.
I can show you tests in small vacuum chambers where little rockets don't do anything in a vacuum chamber. They don't do anything. But again, let's circle back. If you want to say again, if that's your answer, but you're the first ones who have even answered this, who even tried to answer this. If your answer is that there's no blast crater underneath this because when they land, the ash wouldn't move at all, that's
Correct.
fine. I will take that as an answer.
Okay.
That's fine. I mean, that's how you want to explain it. Last but not least, the satellite dish there that you're seeing is not secret technology. That is a VHF transmitter. It is running off a car battery.
Okay.
That thing has a range, maybe on a good day, of 50 miles. And that's Morse code, if you're lucky. I mean, if I drive an hour from here, I lose cell signal. This thing is running off of no power whatsoever. It's not running off this massive generator. If you want to say it's relaying off the thing that was orbiting, that's fine. What are they bouncing off of? There's not enough power to send a signal. And they're supposedly pumping out 10 frames of color video a second and perfect two-way communication through this thing, through 237,000 miles, give or take, and the Van Allen belts. No. In 1969? No. 1969, we didn't even have 1200 baud modems. And you're saying that these guys could do this? No. But again, the general public, all they see is a satellite dish. And they're going, oh, yeah, that makes sense. That works.
Well, I mean, they have solar panels. They have batteries.
Not that much power, man.
But it's not about the overall amplitude of the wave that they're transmitting. It's like, for example, if they're transmitting, I guess, okay, let's do the car example where, you're in the car and you're driving in downtown of a city and you turn a corner and you're suddenly between a bunch of buildings and you lose signal, right? Like the reason why you lose signal there isn't because there isn't enough power in the signal. It's because you've had interference, but there's no interference in space. Like there's nothing.
The Van Allen belts aren't interference. I would question that.
No.
The Van Allen belts don't create any electromagnetic interference whatsoever to any telecommunication, radio communication, any of that. You're going to hold to that? Okay, fine. You're going to hold to that. We'll take it one further. The Van Allen belts, discovered by your colleagues from NASA, 1959, Van Allen, said that it's super, super deadly, big donut, tens of thousands of miles thick. No one should go up there ever, 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 ever. And then almost immediately, NASA starts their space program. They come back to him and they say, how are you going to get past it? He's going, oh, we're going to go real fast. Okay. What shielding did you use? So the question I have, and you guys, you want to answer it, that's fine, yes or no. The question I have is, are the Van Allen belts deadly? Yes or no? If you say yes.
Oh, okay. We're talking about the Van Allen radiation belt, which originates from solar wind.
Yeah. So if you say yes, they are deadly, and the only way to stop radiation, and I know if you guys want to nitpick on that's fine, but it's gold, it's lead, and it's a whole bunch of water. If you want to pick other metals, that's fine. But we didn't use any of that. The Americans went multiple round trips through this thing using plastic and aluminum, which doesn't stop radiation at all.
For sure.
And nobody died. Nobody got radiation poisoning. Nobody got cancer. There's 5 of these guys still limping around today.
Well, I mean, there's people that were in Chernobyl who are still alive. There's a Russian physicist who stuck his head in a particle collider and he's still alive. Just an exposure to radiation.
This is not radiation. Okay, I think we need to remember something. So radiation or radioactive chemicals is different from electromagnetic radiation. Those two things are completely, entirely different. And electromagnetic radiation are not all, only the very, very high energy stuff. So like X-rays onward can be harmful to your cells.
Are the Van Allen radiation belts deadly.
Yeah, so
To-
this is
We got to know the
electromagnetic radiation.
frequency.
This
We
is
got to know the
electromagnetic
frequency.
radiation that can certainly, I don't know too much about the Van Allen radiation belt, but I can tell you that if it's in the range that is deadly, it's coming from solar wind, so absolutely that can be dangerous, but it's not something that if you're exposed to it right away, you're going to die.
What if
This
you
is something
spend
that you need
hours in it?
prolonged exposure.
Like hours?
No,
Like,
so
I
I
don't
mean
know,
there
during
are people that
re-entry?
so it's well known that if you fly in an airplane, for example, you're exposed to more radiation than you are on the ground. You don't die from it though. Same with the astronauts that are
Okay,
in the
okay. Oh,
International
no,
Space
that's fine.
Station.
Again, this is a trick question. It's a trap question because on the NASA website, nasa.gov, there's a little video there called Orion Trial by Fire. It was made at the end of 2014. And they were talking about the Orion project because, Orion, they're supposedly going to go to Mars. And they were saying how, and they were very detailed about this. In fact, it won a local Emmy. You can look it up, Trial by Fire. How they can't test the capsules with people in it because they haven't solved the radiation problem of the Van Allen belts. I don't know why they would say that. Remember, it's NASA, but at that point, you screwed yourself because it's like, okay, so you've just said the Van Allen belts are super, super deadly. So what'd you do in 1969 to solve it? And again, why weren't those capsules just crackling by the time they got back? Geiger counter stuff. Anyway.
Well,
Well,
again, Geiger counter is a different
is
type
not
of
for the
radiation.
same type of radiation.
Oh God, stop. Don't out nerd me on this. You can't.
But it's a Geiger counter does not measure the radiation that you're talking about. That's what we're saying. So, I mean,
You guys, look. Are the Van Allen radiation belts deadly to you? Yes or no? Hannah.
With prolonged exposure.
if
It's a yes or no question. If you're going to spend 3 hours in the belts, are they deadly? Yes or no?
Honestly, I personally need to see the spectral information about what frequencies they're made of. If it's super high frequency radiation, yeah, I would not go there unprotected.
But we're talking about this is radiation coming from the sun, okay? We're not talking about gamma rays, okay?
It doesn't matter. If Van Allen, remember, one of your predecessors,
right, but
comes out and says no one should ever go there, did he make a mistake? Was he wrong?
Mark, but again, we're talking about something that we understand well here. So this isn't again, I want to clarify that Hannah and I don't understand too much about the Van Allen radiation belts, okay? This isn't our expertise. But
then
we do understand.
Again, what you guys are doing, you're doing the whole Mr. Spock on me. Remember how Kirk would always get angry with Spock? It's like, give us your best guess. I know you want to answer in the most detailed way possible, but I'm
giving you an answer here. I'm giving you an answer. I'm telling you that so this is radiation that's coming from the sun, okay? And I guess in the radiation belt, I haven't read enough about it, but ultimately whatever's going on, we're talking about frequencies that are coming from the sun. The frequencies coming from the sun, they can be dangerous if exposed to in high quantities and over an exposed period of time. But so just going through it on the way to the moon won't kill you.
How do you know?
It can be bad for you.
NASA thinks it might.
Well, it can be bad for you, but it's not going to kill you. And second of all, it's also not an explanation for why we can send signals through from the moon to the Earth. I mean, we can.
No. I that was just a secondary thing. For me, it's all about power, meaning you just don't have the wattage to do it.
But again, this is what Hannah was saying, that it's not about the power. The reason you lose interference when you're in a city is because when you lose signals because you have interference. There's no interference coming from the moon. You can sense it. So if you're in a flat vacuum of space, for example, I shouldn't say flat, when you're in a vacuum of space and you just send a signal, then it can travel forever and ever and ever. And that's why we see stars so far away, because there's electromagnetic radiation coming from those stars, which we see as light, by the way. Light is electromagnetic radiation, and that travels forever and ever and ever for billions of years until it reaches our eyes.
A perfect textbook answer. Okay, let's move on to another one.
Yeah,
Sure. Let's move on.
Let's move on because I mean, there's so many things that I just want to learn about from you. Man, I don't even know where to start because, well, I guess okay. Let's just go with this question. Or would you? Is there something you wanted to?
No. Again, I appreciate that you guys are being patient with me because again, you made it this far. Your other two, your two cohorts, they couldn't even make it here.
No.
They would be just beside themselves.
And honestly, Mark, thank you for being here. I really appreciate us having this conversation.
No. Hey, look, I mean, I've done these sort of things before. I've done classrooms of physics people, although that was easier because they were just talking over each other.
Yeah.
So anyway, go ahead, Hannah. What?
So maybe let's go back a little. So you told us what it is that you believe. How did you get to this point? And I know you've answered this before, but I want to know like full detail since this is a platform that we have the time. Like, what did you enjoy in elementary school and high school? And then how did that, what did you think you would be when you grew up as a kid?
Oh, gotcha.
Like how did it evolve? Because I don't think, or at least for me, this doesn't seem like something that just comes out of nowhere. Like, were you always curious as a kid? Were you always
well, no. It
Okay.
happened to me somewhat later. So I grew up on, documentary. I grew up on a rural island up in the northwest corner of the United States, very sheltered from everything. And to the point where I went to university, I didn't even know anything about anything. It's like, wow, so many different things. And on top of being exposed to everything at university, I didn't believe in any conspiracies whatsoever. And by the way, I have an opinion on just about every conspiracy you can think of. I have an opinion. Some I like, some I don't like. The ones you were rattling off at the beginning of the show, I have opinions on all those. But I didn't believe there were such a thing. Why would people in power lie about anything? Why? I mean, I knew people lied about some stuff, but I figured it's like when you reach a certain level of authority, you wouldn't lie because power doesn't corrupt ever. Anyway, so I saw JFK in the theater, way before the internet, and thought it was amazing in that it's like, holy smokes, what am I looking at here? Is it possible, are there things out there? Are there secrets? And of course there's secrets. There's conspiracies in just about every aspect of our lives. There's some that are media sanctioned, some that aren't. And because I never got married or had kids, and I got into tech, I had a lot of time on my hands, tons of time on my hands. And so the internet was new, and so you could actually finish the internet when it was really new. And there, the conspiracy stuff started popping up, and it's like, oh wow, this is interesting. Different rabbit holes. Went down just about every rabbit hole you can think of, to where I ran out of rabbit holes. And then it's like, yeah, what do I do now? I got nothing left to look at. And then all of a sudden, I saw this, and I thought, okay, flat Earth is stupid. It's ridiculous. But I caught myself when I first clicked on it, and this would really, I'm kind of introspective in a way that, when I clicked on the first video, I actually got flushed. And I'm thinking, and I caught myself like, why am I getting embarrassed? I'm in a room by myself with the drapes pulled. It's like, nothing should embarrass me on the internet at this point. And it was embarrassing to click on. I was going, why? What is wrong with me? Right. So I went down this rabbit hole. And I really thought I could shut it down in about a weekend. And that's how everybody gets into it. And I'd really like to clarify is that nobody likes flat Earth, especially when they first get into it. Everybody hates it. It's just most unpalatable thing you could ever think of because of the conditioning we've had. That globe that's behind you, that's been sitting in your classroom forever. I mean, that's very, very strong reinforcement, and that's just a little toy globe. And so I kind of treat it like a court case, and I don't know if I said this in the documentary or not, where I treat it like, could I prove the globe in a court of law? Or was there reasonable doubt? And so, to your science friends, it's like, can I prove to you the flat Earth? Can I prove this thing? Nope, can't. Can I create so much reasonable doubt in the globe, it's the common person, not you guys, that the only place you have left to turn is something like this? Yeah, I can. I can do that all day long. And you say, well, and again, that's where science braces. They go, no, reasonable doubt's not enough in science. I go, well, no, not in science. But in the rest of the world, it is. Reasonable doubt wins every day, every hour in court all day long. And that's how it started. That's where, I hammered on this thing for months. And the more I stared at it, the worse it got. Because there was always these little threads. I'm a huge media guy. So I absorb just about every form of media you can think of. And I'm a big fan of writing and plot holes. I don't, if a show starts, too many plot holes, I'm like, you lose the suspension of disbelief. And all of a sudden the globe started showing these plot holes. And yeah, are there holes in this? Yeah, you bet there are. Sure. The Antarctic sun. As you guys haven't brought that up yet. Antarctic sun, plot hole. but there's so many more plot holes in the globe heliocentric thing that people just kept leaning towards it, and they started doing their own experiments. And I didn't even do the experiments. I mean, when I got into this thing, to your point, Hannah, um, not almost nothing was on the internet. And so I said, I got frustrated one day in February of 2015. And I said, you know what? The internet hive mind is very, very intelligent. People generally are dumb, but the hive mind misses nothing, especially when it comes to media. And so I said, okay, here's what I think. Here's my idea. Prove me wrong. And I was hoping that somebody from your community would say, okay, it's this, this, and this. You can shut down your YouTube channel and go back to your normal life. And they didn't. In fact, I started having subject matter experts start calling me up from all branches of the military, and pilots and structural engineers and air traffic controllers, and people like that start calling me up unsolicited, saying, yeah, it's not that crazy. Here's why. And they start going into stuff. And then people started doing their own experiments, and it just kept reinforcing and reinforcing. And here we are 6 years old. In fact, the clues are 6 years old, 6 days.
There's one thing that you said in there that I actually really, really, really love. You said that I can't so you said, can I prove the flat earth? No. But can I show you things that make you question the globe earth? Yes. And you know what? I love that, because that actually sounds like science to me. Science.
I don't hate science.
We find common ground,
Well, I mean,
this is what science is,
No, I hear you. I taught proprietary software for 20 years. It's not, look, I was a big tech guy. I loved science. But what I started to figure out was, again, no, not offending any of you guys, is that science tended to take leaps just because they could, or because the money.
Is that where you think that? So this is, I think, where we diverge. Because we agree on that point. We agree on the point that science is something that you can never prove something. All you can ever do is reject hypotheses. So you come up with testable predictions that if something doesn't meet your testable prediction, you throw away the theory and you start again, right? That's what science is. But this is where we diverge, because I have two questions here. Sure. A, why do you think all of these doubts that you have, all of these plot holes, as you call them, for a globe Earth, why do you think that scientists never found them before you? And second of all, why do you not do the same with plot holes when they're found with the flat Earth model?
Oh, no, we do. We hammer. That's just it. We know everybody goes into the flat Earth trying to debunk it. That's how it all starts. It's not, again, I don't go, it's like, I'm going to prove this. It's like, no. Everybody stares at this thing like a simple child's toy and says, oh, this is the stupidest thing ever. I should be able to shoot this thing down. And that's the trap. It's kind of like a Chinese finger puzzle or La Brea tar pits. You get sucked in, because the more you think about it, there are dedicated trolls now that with channels just every day trying to hammer this thing out, and they're not convincing anybody, because, and it was talked about in the documentary, you may have missed it, which was the reason why our retention rate is so high. It's like, once you get into flat Earth, it's like a 99% chance you're not coming out of it. Why? Because I didn't convince you. I didn't persuade you. You convinced yourself. You went and you chipped away. They did this kind of cool little graphic. I didn't even know they were going to do it. They showed something like chipping away at the globe on their own. Well, if you're the one that tore down the globe in the first place, you guys wouldn't, because you're in deep. But the average person,
I guess, can you explain that maybe? Like, what does it mean to be in deep, and what is, I guess,
because we want to be wrong as scientists, We want to be wrong about our theories, because that's how we progress. So why would we not want to tear away our own theories?
No. Well, it's not that you don't want. It's nothing to do with wants. It's that, and I said this, look, if you have a master's degree in any physical science or higher, I joked about this years ago, then you're probably not coming back, because you are so invested in the financially, the time spent, not even emotionally, but you're so invested in it that the paradigm shift would be too much, even if you wanted to. Kind of like the pilots I've been talking to.
But do you think we're lying, or do you think that we are just...
No, I don't think you're lying. Not at all. You firmly, absolutely. If you gave both of us lie detector tests, we both pass. Right. The question is who's right in that case. I mean, is it a matter of perception, like the white dress, black dress thing, that photograph where you saw it at one or the other? You could give people in that very same room looking at the exact same image and lie detector test, they would both pass. No, it's not that. It's just that you have been, it is your belief system that you've been going down. Come on, we'll compare it to religion. It'd be like trying to convert somebody from Christianity to Islam after 20 years. It's tough to do.
But it happens.
Well,
Yeah,
I also want
often,
to
though.
hesitate by making the comparison to religion here, because I'm saying there's nothing for or against whether we should have religious beliefs, but I mean, science is a very well-defined thing, and religion is something that's very hard to define. So we shouldn't get into comparing apples and oranges.
They are slightly different. I get why people want to compare the two, but I think there are very distinct differences between science and religion, and we don't have to get into that.
But science has, and I know you probably don't like the word, science in some places has kind of evolved into scientism in a way where people believe. I'll give you a quick example.
Yeah, unpack
if
that.
You're wearing, I did a video called The Code of Credibility, which is, look, if you put on a lab coat and you're holding a clipboard in the street, people will talk to you because you are instantly more credible because you're wearing that lab coat. Bill Nye's entire career is based off of a lie. And it's like what? You literally just put a lab coat on him. Same thing. Again, I know big separation. I know between religion and science. They are mortal, not necessarily kind of enemies in a way, but there are some similarities. What I try. Let me throw this one more thing out, which is science tends to, they're no different than anything else. They're men and women that can be influenced by certain things. Pure objective science, I love it. If the planet Vulcan, great, love that. The whole concept. If everyone could be like the planet Vulcan, I think that'd be a fantastic concept, but that's not the case. Scientists tend to, they can do things for ulterior reasons. You know what I mean? I mean, most of the time when they're trying to make quarterly profits for a corporation, I get it. They need BMWs too. Anyway, sorry, I went off the way. What else do you want to talk about?
I guess my question is now, and you've alluded to this several times, is there's regular people, yes, and they can't believe in science, or they can't really understand what science is really, because science is overcomplicated. It's too complicated for them to understand. But on the other hand, there are a couple people who have decided, I'm going to do this. I'm going to put myself to this challenge, and I'm going to go and learn and understand it all. It's not easy. I guess, let me put that out there. It's not easy to learn physics. It's really hard.
No, it is not.
Hard. So hard.
Physics club, really, really small.
Yeah,
really small group.
Really small. Because it's hard.
Yeah.
And I understand that not everyone wants to devote themselves to that. But I guess, I don't know if you should assume that people are too dumb to ever understand physics. Why should we make people settle? It seems like we're making people or we're making people settle for the flat earth because we don't have faith that they can learn the real physics that is required to fully understand all of the globe earth. Just because something's hard to understand doesn't mean it's not true.
No, you're absolutely right. But it's the first part, but it's still hard to understand. And I've made this plea to science for some years now, which is, look, until you come up with, and it is the blessing and the curse of science, which is you get to a certain point and your thought patterns and all the work and time and yes, you focused and you've got it. The problem is when you reach that point, you don't want to make it available to the common man. And maybe want isn't even the word. You're not going to, because the reason why your friends aren't here, it's beneath you. Well, that's a problem, because the masses, all the people that weren't in physics club or math club or chess club or any of the other clubs, is because they barely made it through school. The masses are a huge, huge group. Mm-hmm. And they want something that's easy to understand, which is, again, why I put it out there. I go, look, if the globe wants to fight against flat earth, great. The heliocentric model wants to fight against flat earth. You better come up with some Schoolhouse Rock version of it. You guys old enough to remember what Schoolhouse Rock is?
Mhm.
The if you don't do this, I mean, again, our numbers just keep growing and growing. I've talked to a lot of people that, in this, and which is why I will say this: the documentary did get this right. Was at the end they were trying to create this dialogue between the scientific community and the flat Earth community. They were trying, they were
Mhm.
saying, "Oh, but they were only suggesting it. They didn't actually. It didn't actually happen." I think
Right.
even the documentary team tried to get us together, and we're more than willing. I was like, "Oh yeah, we'll go talk to you." They're like, "Yeah, we're not going to talk to those guys." And
Right.
with that. I'll give you one more quick example. I was down in Los Angeles, shooting this thing, and this one TV group, and I just chuckle every time. It's like, "Oh no, we'll get a physicist to come debate you on blah 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 show." You're not. You're gonna fight. And they called everybody: UCLA, USC, Stanford. They called everybody.
Well, next time, tell them to call us.
Yeah.
We'll
We'll be
have
there.
to go.
You're up in the mythical land of Canada.
Yep.
There's a lot of people don't even know that's a real thing. By the way, I didn't even know that Victoria was a real place.
Victoria, BC.
Oh, like
Yeah, everyone in America thinks that Vancouver's it, and then there's nothing else.
no, you can go further west. Yeah.
I
You-
knew this. I lived in Victoria for a year, and
Oh,
it's
wow.
like I went up there and it's like, what is this place? Is it full of unicorns and Bigfoot? And it's like, wow, this is great.
So, Mark, something
Yeah.
interesting that you were hitting on there is that you were saying that we as scientists should be able to make an easily digestible version of our science for everyone to understand. But what if you have something that's just inherently difficult to understand? I mean, why does something have to be easy to understand to be true?
Well,
like for
again,
example, oh, sorry. Go ahead.
well, no, that was Hannah's question, which was why it was just a rewording of her question, which is
Okay.
just because I don't get it. That's kind of Neil deGrasse Tyson, isn't it? It's like science is true whether or not you believe it or not. What your version would be: science is true whether or not you understand it. It's like maybe,
I mean, I
except that
guess it's the same kind of thing as like I don't know, like a tech product, right? Like your computer. I personally am not a computer hardware engineer. I don't know what's in my computer that's making it work right now.
sure.
And just because I don't know how it works doesn't mean I know it works. Or for example, I don't know if I don't know if we want to go down this rabbit hole, but like medicine. I don't know if you know,
I believe it. I believe in medicine.
okay. I don't know how many
You don't have to be
conspiracies we're
gentle, by the
going
way.
into.
But she said Hannah's
Medicine.
Like
sitting on a good point
medicine.
here.
My God.
Why
Rub some dirt on
she's
it.
sitting on a really good point. I mean, you trust medicine, you trust airplanes, you trust cars. We don't know the exact science behind those, but why do we trust those and not other
Well,
parts of
but
science?
we know actually quite a bit. You got to remember, there's a lot of blue collar people that work in the automobile industry, not necessarily in the engineering side,
Mm-hmm.
but everything like the phones that you use were just an evolution of the early PCs. We just made them smaller and smaller and faster and faster.
Mm-hmm.
But again, they were a hands-on type of deal. Now, if there was a box, a magical box that did something that we just found, and no one could explain how it worked, but we just, it's kind of, I'll show you. There's a quote I had. Sometime I've said this for you. I've never said this on air, which is science is just magic without mystery. Meaning, once it
I
became
find that concerning.
repeatable, science put their stamp on it, and then that was it. And it was like, oh well, as long as we can repeat it, that's fine. But when the general public can't, when you're talking about things that are outside our world, things they can't get a hold of, they have a tough time with it.
It's
They have a
funny,
tough.
Mark, because you say that science is magic without mystery. I would define science as mystery without magic. I mean, these are things that we
I like
look at
mine
these
better.
crazy things happening in the world and our minds are blown, but we can learn, we can appreciate to understand these things very well and know how they work.
But
There's no magic going on.
they start out as magic, meaning that science
They start out as
something
mystery.
that it used to be, whatever it was, like, oh yeah, you distill this, blah blah blah, and it, in the early days it was just, trial and error, and lots of people died or poisoned and did horrible things, and then science broke it down and made it safe in a lot of areas, and then they took the they turned it from something that was absolutely incomprehensible into a solvable mystery. How's that? Is that a little better? Solvable mystery, maybe. This is not
Sure.
as doesn't roll off the tongue as easy, but
I
no,
guess. Oh, sorry.
sorry, you had a thing. Yes, I do believe, but to your point, the conspiracy crowd, especially when you get into flat Earth, questions a lot of stuff after that. And yeah, they do question some medicine things, and we don't necessarily want to get into that here. That's a whole nother thing. But yeah, they are suspicious about a lot of stuff. There's a couple sayings. One is trust everyone but count your change. Don't take anything completely for granted, because again, there are people out there that will do things for ulterior motives. And science is not incorruptible. That's what I try to tell people. Look, they do make some big mistakes. The only beef I've ever had with science, and I know it's just the nature of it, is that again, if you're wrong about something, there's no apologies. It's just that, oh no, we're just reclassifying it. Sort of like we're just going to put it under a different label. We're going to recategorize it, put it back in the filing cabinet. It's fine. It's totally fine now.
Well,
But I get it.
I don't. I think that scientists don't necessarily apologize if they were wrong, because every scientist goes into science knowing that they're probably going to be wrong one day. It's just a
I'm
part of the
wrong every
process.
day.
Yeah,
I'm
it's
always
just
wrong.
exactly.
Yeah,
but it's being wrong that shows you what is better. And
We
it,
embrace being wrong. You know, it's a process of learning.
yeah, and I guess another thing is that I was thinking about while you were discussing this is, okay, if the globe Earth is kind of magic, what's to say, like, to me the flat Earth seems like magic. Like, it doesn't seem like it's equally not proven. Like, someone has not gone up in a you know, no one has ever seen the disc on its own.
Right.
It's so I guess.
But that feeds into the conspiracy crowd, because who controls that access? Military.
But like you said, if there are people in the military who are willing to provide that information for you, then
Not in aerospace. We've gotten everybody else, but we haven't gotten aerospace is a tough nut to crack. And really, I'd be stunned if we could get anybody from aerospace.
well,
Well,
Alex is in aerospace.
I studied at the Institute for Aerospace Studies.
No, you know what I mean. Full blown Scott Kelly,
Like,
Terry
would a
Virts.
would a pilot, like a military pilot, is that aerospace?
Oh no,
enough?
I've had military pilots, but for example,
Okay.
when I had a chance to do a debate with Terry Virts on some British thing, and they asked me, Piers asked, he said, he goes, "Are you calling?" He's trying to stir up drama. He's going, "Are you calling Terry a liar? Aren't you American?" And I go, "Look, I'm not saying that this astronaut here is a bad guy. I'm saying he's a soldier. He's not only that, he's a colonel. He's a full bird colonel in the United States
at this
military."
point, though, the amount of people that have to be in on this conspiracy is ridiculous.
No, absolutely not. Very, very few people. This is one of those things you normally would be right. This isn't like the Manhattan Project, where you have people refining things in 3 different parts of the US and you keep the whole atomic bomb secret. This is where the only people that have to be in on it, honestly, are the software guys, the telemetry guys. Everybody else, the guy polish fuel system, make this, make that, and even the janitor that's 99% of NASA doesn't have to do anything.
Well, I don't know. I mean, you do need people that, for example, everybody that works on the satellites, that people like at Google, at SpaceX, that also work on satellites. I mean, how would satellites work? They all must be in on the thing, because they need to take into account things like special relativity and the curvature of the Earth and how they map where the satellites are around the world. I mean, these all depend on a globe model. Not only that, but what about, like you're saying, I don't know, pilots that fly through the southern hemisphere, or weather stations, meteorologists, people in shipping companies,
Nope,
FedEx,
none of those guys.
DHS.
Nope,
None of those
them.
people.
Nope.
None of the
No, in
people that I
fact,
mentioned.
this is one of those things you would the less the amount of people, what's the word I'm looking for? Less is more in this case. You do need to know. There's no better example of need to know than this one is. I use the movie Capricorn 1, where they were faking a Mars mission. The United States government was doing it for safety reasons, because the rocket wasn't going to work, so they faked the whole thing. And they did not, it's very few people knew about it, and they monitored anyone that potentially could slip into it, and if they did, they were taken out of the loop. No, you don't. You don't tell
The thing
anybody.
is
And as far as the
that
weather
it's not.
stations, by the way, the Antarctic Treaty was one of the big things for me, which was the Antarctic Treaty is no joke. The general public knows nothing about it. It's bulletproof. It's the only unbroken
Well,
treaty in the history of treaties.
I think that's what you're talking about. That no one can lay claim to Antarctica, correct?
Not even lay claim. You can't even go down there as a corporation and set up shop. Doesn't matter how much money you have. And that just was a massive red flag for me, because our world, you guys know this, is based on greed and money and power. Not necessarily in the lofty levels of academics, but in the rest of the world, it's greed and money and
Well,
power.
maybe
Yeah.
even in academia.
But means
But
if
not
nine out of
that,
every 10,
not to the same degree. Like
Not to the same
scientists
degree,
don't
no.
make like what is considered a good sum of money. Like
oh no.
scientists-
What I'm saying is 9 out of every major 10 problems in the world are revolve around money or resources. And in
Mhm.
this case, they did exactly one of the qualifiers I've always had for going for looking at a conspiracy is I put myself in the other person's shoes and I say, okay, do the ends justify the means? Is this conspiracy being done for the greater good, and would I have done it differently? And when they locked Antarctic down the way they did, exactly how I would have done it. Which was they knew it was like there's issue. I mean, the whole place was made out of money, huge amounts of resources that the United States figured out in the 1950s. And in fact, they were worried. It's like, oh man, we're going to have conflicts down there for the next 100 years. And then they come back and they say, no, we're locking this thing down, because they realize that you can't have that many people out there. All you need is one plane that goes off course, or a helicopter, or a massive oil corporation that does the wrong thing. You can't risk it. So they just said, nope, we're going to lock it down. In fact, it's not even up for review until 2041. That no, it hasn't even possible. It's amazing. And oh, by the way, not only are you not allowed to do anything, you're not even allowed to talk about it. That was the big one, which would say you're the owner of British Petroleum. Oh my, you would run full page ads in the London Times every month saying how great it would be to go set up shop in Antarctica. And you're not allowed to do that. Why? It's easy. National security.
Well,
Okay.
do you think
I mean,
that
Groom Lake exists. We all know it's there, but it's a not very well kept secret. There are secrets that can be kept.
Well, okay, I think we're getting a little bit into the weeds here because, I can tell you, we can argue here that there have been people that have gone to Antarctica, and we can argue the different reasons for why the treaty's in place. I don't think we're going to get to any conclusion there. What I want to do, if you're okay with it, is go back a little bit to talking about how it's on this conspiracy is on a need to know basis.
Yes.
Because my opinion here is that even if it were on a need to know basis, science, physics, technology, it wouldn't work as we have now. I mean, physics as we understand it now is such a self-consistent theory. You can't have some parts that work and some parts that don't. If this theory were built on a lie, then you're talking about somehow the government would have had to come up with this incredibly detailed, incredibly self-consistent theory that explains almost everything in the universe as we know it today.
What universe?
Oh, well,
I guess
everything that we
again,
see,
I mean,
everything that we're
if
able
it's
to
just,
observe.
if it's just lights on the ceiling, then what universe are you talking about?
Well, I guess, okay, here's a question, I guess, off of what Alex just said is, there's this giant conspiracy, there's stuff that governments want to hide, so they start, proposing this globe Earth model to hide it. And they're trying to hide it from who? From the masses,
Sure.
like you said.
Sure.
And you also said that the masses can't understand complicated things. Why would they have not chosen something easier to understand than physics, which is so complicated? Why would they choose that?
You mean why would they allow physics to happen?
Yeah, why would they allow is physics fake?
Because
I guess
the people that run. All right, I will speak this as a government agent. I will throw this out at you. What do we do with the uber nerds? No offense. What do we do with you guys? Well, just let them run with it. Let them come up, because they're going to argue about all sorts of theories for the next so many decades anyway. And the general public's not going to understand any of them. So let them publish their papers. Let them get their PhDs. Let's go. In fact,
but the thing is, Mark, that doesn't work because the PhDs that have been published would not have worked under a flat Earth model.
Again, what do you think the flat Earth model is? Meaning we just say whatever's in the sky is in the sky. You guys are the ones that define it. If you want to define it, you can define it any way you want. You want to alter the speed of light? You want to talk about space-time curves? You want to talk about wormholes? You want to talk about all the other Star Trek-y stuff? Fine, go ahead. It doesn't change our view at all.
So I feel like at the core of this issue, it's not a matter of, we don't necessarily disagree on what we see, but we disagree on that scientists or physicists, as we like to do it, we want to find a self-consistent theory to explain things as we see it. Whereas flat earthers, and correct me if I'm wrong, but you guys want a easily digestible idea that can be reduced down to, we don't understand things and that's just the way it is, and maybe I see things that are different to what you see and we don't need to explain it further. That's kind of the
change. Yeah, something. It's kind of a long-winded version on your side, but my side is this: we turned the universe into a studio apartment. That's all we had to do, and for everybody in our community, it works just great. Again, because it's easy to explain. You want to find, again, not picking on Hannah here, because it's her field. It's like, look, cosmology is great. If that's what you think the definition is of what's out there, fantastic, great. We think it's easier, and that's just what we go with. But yes, yeah, I mean, and by the way, there doesn't have to be a massive conspiracy about that, because it works itself out naturally. Because your thought types, you're going to keep firing off, mentally and saying, okay, this is what this is. But you know full well that 100 years ago, that was different. And 150 years ago, it was, in fact, even 20 years ago, you have different thoughts. You guys are arguing constantly about cosmology, about what's going on.
For sure.
Which is great.
But I guess there are a couple of things. We're arguing about things, but it's not like we're just having arguments. We build telescopes and we build experiments to look up at the sky, and we see things up there.
Right.
And, they agree with our models.
Sure.
And I guess the issue I have with the flat Earth is that it doesn't make any concrete predictions. So, but by that I mean, you say that, okay, the globe Earth is this model, but I can cast a doubt on it being correct. Based on XYZ.
Sure. And for every one of yours, we can come up with 3 on our side.
So
and we can do it on the ground, and we can do it with things that the average Joe lunchbox can run to the beach and do with an HD camera.
But what about the things that you do with more complicated instruments? Like, shouldn't those things also be consistent with your model?
What complicated instruments would you be talking about?
For example, if I take a radio telescope and which looks at things based on our current understanding of cosmology, we take a radio telescope which measures radio waves from the universe.
Sure.
And based on our understanding, if something comes from radio, if we look very, very deep and we see radio waves, it means it's coming from something from a very, very, very long time ago. We can make these more complicated observations and explain them. But I feel like, for me as a scientist, if I were to switch sides, I would want all of my science accounted for, I guess. That's what I need.
You're not going to get all of it, but then again,
why not? Well, then why is it a good theory to accept if it can't account for everything?
Because
is it just something to believe in because you want to?
No, not at all.
Okay.
Because the stuff that because the main experiments, the main points that we came up with, anyone can do. And you can do it on the ground. First off, when you say, oh yeah, you take a radio telescope, it's like, I don't have one of those lying around here. And neither do any of my friends, a radio telescope. But what we do have are HD cameras. The thing that convinced so many people when it came to this was the lack of measurable curve visually. And by that, I mean looking out into the supposed horizon.
But that's something that is explained as well on a globe Earth model.
Then
It's
why are we
just
still
locally,
here? Why do we keep
locally
growing?
you see things flat because the curvature is so large.
Nope.
And
Nope.
also,
No. The
but
curve. Do you
when
even wait? No, I got to call him out on this. Do you know what the curvature formula is?
Do I
Tick,
know what the
tick, tick,
curvature
tick,
formula? What
tick,
do you mean by
tick,
that?
tick.
I know what
Come
the
on,
radius
man.
is. I
The
know what the
curvature
radius and
formula
the
is 8 inches
circumference.
per mile squared, otherwise known as 8 inches per mile per mile. Don't feel bad. I had to look it up too because I hated high school algebra. But 8 inches per mile, which means at like 10 miles, it's 10 times 10, which is 100 times 8 inches, 800 inches, and it gets worse and worse because remember, it's a curve, it's not a staircase. Well, that means that off in the distance, eventually something is going to be on the other side of the hill. It's going to be on the other side of the curve. And
right,
that's a problem because all the people, and I didn't encourage it, they just came up with this on their own. They started running out to bodies of water because water lays perfectly level, especially if the weather's nice. And they started seeing things way, way further than they should be, way further. And remember, the game changer here was HD technology. 20 years ago, you couldn't have done this. Now, with $400 and a camera, you can
Well,
just
I
shoot.
don't think that's
but
true, Mark.
but
I
the
mean, like
What are
you
you
do
talking?
see
We've
see
got literally
boats.
1,000 videos out there
No,
showing
I mean,
all
like
this
yes, you
static
see
objects,
things.
moving objects.
but
You
it's
see things far away, but you also see them disappear underneath the horizon.
No, you don't. No, you really didn't look into this before you got a hold of me, didn't you?
No,
I
no,
could
I've
give you.
seen
we've
this.
seen
We
the
have.
videos.
Okay, did you see the oil rig ones that I had that was leading my experiment playlist? The oil rigs, one at 6 miles, one at 10 miles.
But the
Nope.
thing is, though, so okay, I'm familiar with certain experiments that flat earthers have done where you see further than you should,
Yes.
basically.
Yeah.
But you don't see all the way. I can't look here and see. I'm okay. I'm on the east coast of Canada.
Why
I can't
can't you
look
see
east.
Europe from New York? Why can't you see Japan from California? Why can't you see Mount Everest from everywhere?
Sure. Or why
Why?
can't Mount yeah.
Come on, you know this. Come
I mean,
on.
there. I
You
mean,
know
you can.
that
Oh, I
there's a
know why.
I
because
know.
the
I know
atmosphere
what
the
you're going
atmosphere's
to
too
say.
thick. We're breathing in again. I'm not picking on you. The
Okay.
average person doesn't even know what we're breathing in right now. We're breathing in 80% nitrogen, 20% oxygen. Yeah, I know there's some trace gases. I'm just rounding up on
Okay.
both sides.
Okay.
Which means there is a thickness to it, which means it's only 99% transparent. No different than water. If you go diving 200 feet in a summer day, you will lose the sun. It's gone. Why? Because the sun rays cannot penetrate the water. We're basically living in a thin version of water.
Well,
We're
that's
basically
not true
swimming.
because you can see the sun coming through the atmosphere. You can see the
I
light
mean, it
from the
has to
sun
pass
coming
through the whole atmosphere.
Yeah, that's my point. The point is the sun doesn't set. It just fades off in the distance. If you had a filter and zoomed in with your cameras, in fact, we can pop the sun back up. You can watch the sun set, you crank up the zoom, it pops back up. You crank it up, it pops up again. And then eventually it just fades away into the soup that we're living in right now. And we can see this with just about everything.
I don't think that's true, to be
I,
honest.
I,
You can't
I
zoom
mean,
in
it's not
and see
true.
it
I've
again.
got how much
I would love to
evidence
see
do I
that
have to
video.
show
You can send it to me after.
Again, this is cognitive dissonance right here. You don't. Here's the difference. You don't want to believe it, and I don't blame you. I don't. But again, you want to know why our community just keeps trudging on like we're doing? That's the reason. It's because I didn't convince
Well,
them to
I'll
do
tell you
anything.
what. I have seen explanations for why the sun supposedly sets, and I want to know if this is one that you believe. They believe because as the sun goes far away, you should see it just getting smaller and smaller and smaller and smaller until it's a point essentially that you can't see anymore. That's not what we see. Okay, we see that it literally goes below a horizon. Okay, and the explanation for that's on YouTube is that supposedly the atmosphere is like a curved lens, and therefore it appears that it's setting even though it's just going
we
farther
didn't come
away.
up with this term, by the way. It's called atmospheric lensing.
Mm-hmm.
And meteorologists, I know it's not your field, meteorologists came up with it, and I didn't even know it was a thing, which is, by the way, why some things get chopped off. Because if you take a magnifying glass and you zoom in on something, you chop off the top and the bottom of it. I'm sorry, you pull back from it. You can make, in fact, you can make a flashlight set on a perfectly flat table with a glass of water in front of it.
Sure, and this is exactly what I wanted to bring up because that doesn't
The flashlight didn't
work.
set.
No, so it works with a glass of water, sure, but the atmosphere is not a glass of water. And so
it
yes,
is.
there is this thing. There is
It
this thing
is
called
a glass
there
of
is
water.
this thing called lensing. You are correct about that. But so the extent to which this has an effect does not explain a setting sun. Okay,
Sure
these
it
are
does.
very measurable amounts of things that you can exactly predict how much a light ray is going to bend. It doesn't explain why the sun would set. Second of all, it's
It would if the sun was 50 miles wide.
reason why light bends is actually due to the curvature of the Earth. Light bends when it goes through varying densities of air. Okay,
And yet when we do
if
laser experiments, the
if-
laser doesn't bend.
No, that's not what I'm saying. I'm saying that if the Earth were flat, so if light was just traveling in a straight line on a flat plane, then there would go through no changes in density and it would never bend. On a round Earth, however, when it goes through parallel to the Earth, that's when it's traveling through different densities of air, because now it's all of a sudden traveling through different columns of air, because straight line and a curved line do not they don't match. So that's when it's going through different densities, and that's when it bends.
A perfect textbook answer.
You don't have bending on a flat surface. And I'll tell you even a third point is that sometimes atmospheric lensing curves the other way, and that's when you see things like mirages. Things are bending the other way. So there would absolutely be times where we should see New York, because why wouldn't it bend the other way? You can have fluctuations in density, temperature, pressure, whatever.
The only way you could ever see New York on a flat surface is if it was a pure vacuum. By the way, why would you think there's no layers in a flat Earth?
It's not that there are no layers, but what Alex is saying is that
when light is traveling horizontal, you're not going through those layers.
You're not going through the layers.
Let me do one more thing. I want to throw this at you because I know that both of you want to address this one, because it's my second point. Because I bring up five points when they say, if you're talking to scientists, what points would you bring up? And long distance photography is always the first. But my favorite though is gravity versus the vacuum of space.
Sure.
So quick thought experiment.
Okay.
Because the movies get it wrong most of the time for dramatic license, which is if you had a vacuum chamber above you in your second floor of your house or apartment or whatever, and you have a valve and you pop it, what's going to happen? Well, it's going to be instant equalization. It's going to be violent. It'll be a fraction of a second. It'll be horrible, right? The question is, why didn't gravity keep the air in your room instead of firing it upstairs? Why? Because vacuum will beat gravity every single time. I mean, you can do this with a straw and a glass of water. It's very, very powerful.
It's pressure, not vacuum.
Don't dissect it.
But it doesn't matter.
For the argument, don't dissect it.
Okay,
I know
sure.
that's in your nature to dissect it. Don't do it. So the question is, when you go outside, why is our atmosphere still here? And your initial knee-jerk reaction will be gravity. So then I come back and I say, fine, what happens at the bleeding edge of space? What happens when our atmosphere ends and the vacuum of space begins? What happens there? Because that, as far as I know, completely blows away that law of thermodynamics, meaning pressure versus non-pressure, molecules versus non-molecules. It has to equalize, and it doesn't. Why not? Is your answer gravity?
Well, I think that there are other processes that keep the atmosphere in place. Like, I think there are like magnetic effects. This could be. I'm not like super
That's actually
familiar.
pretty good.
I'm not super
you were
familiar.
You were the first person to even come up with an alternative to that.
And
That's not terrible.
Mark, to be honest, there are gases that do escape.
Yeah, there are definitely things that escape. Like there's
Why
no
doesn't
question.
everything? No. Why doesn't everything escape?
Well, where did
Knowing
the atmosphere
what
come
vacuums
from?
can
The
do.
atmosphere. Well, where did the atmosphere come from as well? You do know that these gases, where they come from, is that so we are in a process of equilibrium right now, right? So we lose gases to space, absolutely, at a very slow rate because gravity is strong, okay? But we do lose gases to space at that outer equilibrium, like you say. But we're also getting gases from space from things like meteors and asteroids, and when things collide into space, they are vaporized and they become gas. That's how the atmosphere got
So
here in the
there's
first place.
no other possibility. There's no other answer. That's got to be it.
Well, it's well
not
understood.
not that we're living actually
well
in a
understood,
pressurized
and
system.
we see this. We see
Doesn't
this, for
the term,
example,
by the
when
way, doesn't the term greenhouse gases mean? Doesn't it make more sense if it's an actual greenhouse? Doesn't it? If it's an actual physical barrier that you're inside a building.
not necessarily, because we also understand well how those greenhouse gases trap.
And those greenhouse
radiation.
gases and all the other gases, they don't get ripped off by the biggest vacuum of all time.
Well, that's what I was saying. So they do slowly get ripped off.
Why
but
slowly?
because gravity is quite strong, but
Nope.
like I'm saying, it does happen. Gases are lost, but we're in a state of equilibrium where we're getting gases from things that are coming into the atmosphere and getting vaporized.
I agree that gravity is definitely the dominant effect of why the atmosphere is on
Has
the
to
Earth.
be.
Like I
Has
don't
to
want to
be.
say that like there are magnetic effects or electromagnetic
Well,
effects that keep it on.
don't
There are
backpedal.
definitely
Don't backpedal, because that's actually not terrible.
there's
At least
definitely
you suggested something.
there's definitely like I think there are contributions for like ionized particles, like why ionized particles stay within the Earth's atmosphere. Like I think there are electromagnetic interactions which keep things together. But I will also say, because people might say, well, not everything in the Earth's atmosphere is ionized, so what happens then? So and most of what's in the Earth's atmosphere is not ionized. So yes, but what I will say, but it isn't my understanding that like isn't one of the outer layers of the Earth's atmosphere the ionosphere, which is full of ionized particles? But the vacuum's not sucking it out. Like it's
Spitballing, Hannah, you actually are right, because the outer spheres of the atmosphere, that's where they're exposed to solar radiation, and that's going to be ionizing particles. So that's actually a good idea.
sure.
Maybe
Like
there's something to that.
Like a
I mean,
barrier?
but the thing is, I mean, like I don't want to misguide people who are scientists who are listening to this, who are like, oh my god, the like.
That's
That's
okay.
not
They're
real.
gonna say gravity. That's
gravity.
All right.
I mean, I agree that gravity is the dominant effect of why the atmosphere is on the Earth, or sitting
But
around.
it couldn't
the
keep
Earth.
the air in your room, Hannah. Couldn't do it.
But the thing is, I think we need to understand that gravity is it's a force of scale. I guess I think people underestimate how gravity is actually the weakest of the fundamental forces of nature, but it acts on the largest distances. It is the weakest, but it acts on the largest distances, and it can very quickly beat out other forces of nature very quickly. So the reason why, if you're in a room and you have one level of your house that's a vacuum, I think this was your example.
Sure,
You have
for
one
just
level of
vacuum chamber above you.
You have a vacuum chamber above you, and you pop it, and all of the particles go into thermal equilibrium with the vacuum and spread themselves out homogeneously over that space. The difference in gravitational potential between where they used to be and where they go just above you is like is probably unmeasurable by our best instruments. Like the difference in gravitational potential is so different that thermodynamics wins in that scenario. But when it comes to the entire Earth, gravity wins every time.
Well,
gravity
again,
wins at
from
that
your,
scale.
From your side, it has to, because it's the only explanation.
I mean, it doesn't have to, but it does. If you do out the math, if you write it out and you do the calculation, it does.
And these are things that you can measure too.
Again, couldn't keep.
You can work out all the forces.
But the thing is, the room is a different.
Wouldn't matter
scenario.
how big the room was. We can do this with, and I've seen it done with big rooms. Vacuum is a main. Well, let's just call it what it is. I mean, the pressure versus non-pressure is extremely powerful. Was that nature abhors a vacuum?
But the thing is, the pressure difference, like it's a gradient, right? Like the atmosphere isn't just thick atmosphere, then straight up to vacuum. It's a gradient of.
I see the wheels in your mind cranking on this one, but sooner or later you have to get to, unless you say, and I've had people come back to me and say, well, no, space isn't a vacuum. It's like, what are you talking about? It's literally a term.
Mark,
I mean, it's not a formal vacuum, but I get. But we'll call it a vacuum for the sake of this. Like it's extremely low pressure, like compared to what we're dealing with on Earth.
But here's another thing that I think we're forgetting about. That right now, if we're doing this experiment at ground level, there is pressure from all sides, okay? The reason why the air will rush upwards is because there is pressure acting on the air in every single which direction. It's acting up, down, sideways. That's why it's in equilibrium. The moment that you take out some pressure from the top, and that's what happens in a vacuum. There's no longer pressure coming down from the top. That's why the pressure coming from the bottom overwhelms it and will push the air upwards, okay?
And
If we're now at the top of the atmosphere, there's very little pressure, okay? Because there's so much less air being pushed down upon it. So there's no pressure, almost insignificant pressure at the top of the atmosphere. So this atom at the very outer edges of the atmosphere is not being pushed up, down, sideways, in any which direction very much. It's really not being pushed around. So the dominant force acting upon it is gravity pulling it down, and that's why it tends to stay.
You're reaching. You put a basketball in a vacuum chamber hung by a thread, it's going to expand uniformly until it bursts.
Well, no,
and that's a vacuum coming in from all
pressure,
sides.
But because we're doing it in an environment in which there is pressure, as soon as you take pressure out of the equation, we're not going to see the same effects.
Why would you take pressure out of the equation?
Because we're in the upper outer atmosphere where we're in a vacuum by nature.
It's just much less, but that's not the point. Shrink the macro down to the micro.
That is the point, Mark. That's exactly what I'm saying, that the same experiment is not going to have the same result down here versus up there. Down here, you have significant pressure pushing the air upwards when you remove the vacuum. In a vacuum, practically, the top of the atmosphere, you don't have that same pressure acting on the particles, and so it is not going to explode upwards into the vacuum because you don't have that pressure pushing it outwards.
You're thinking too small. Think this. In fact, let's go the other way.
I feel like you don't want to accept my explanation, Mark.
The world is this big, right? Right now, in this room is the vacuum chamber. What happens to the air on it? You're telling me that air is going to stick to the ball that's this big right now? Of course not. Of course, it's going to be
because it's being overwhelmed by the gravity of Earth.
This little ball in a vacuum chamber the size of this room.
So again, Mark, I feel like you're not.
I know you don't want to see it. I know, trust me. And this is why I say it is tough talking to you guys sometimes, because your minds are already so far down that road. You're not coming back. But that's okay. I don't blame you. It's okay.
But I guess it's not that we don't want to. I mean, like if this is really true, I mean, I want to know the truth as much as you do, you know? It's not that I just want to believe in science for the sake of believing in the science I was taught. Like, in fact, I hope that one day I do some science that is new or that disproves someone else, you know? That would be great if I could do that one day.
Well, sure, you could publish.
I mean, more than just that, I think, like, for all of us, like, I guess, because for you, what I imagine the purpose of believing in the flat earth is, overwhelmingly, is you get to tell people the truth. Like, you get a satisfaction out of knowing what's really true about the world. It's not that you can publish it because
no.
Or is that
in
not
my case, the documentary was spot on. I mean, they caught that part right, which was I don't want to do this. I don't like talking to people every week about this. This is just something that fell in my lap. I mean, completely unsolicited. I don't even have an agent. People just started calling and saying, "Hey, tell me more about this." Like, oh well, this is what I think. You know,
right.
See what.
But do you think Flat Earth has given you a purpose?
It's not the purpose I wanted. I was perfectly happy, playing video games and doing tech stuff and drinking wine in Colorado. Totally fine. This is more of a curse than anything else. So don't ever think, if you're going to go down that road and say, "Oh no, he's doing it for the fame and the chicks and the drugs." God, no. Do you really think I would go out of my way, out of all the topics to pick Flat Earth? That seems like a great idea. I'm going to turn that into a media thing. God, no. No, I mean, I was literally just trying to find the answer to something on the internet. The dumbest move I ever could have done. It was like going into a forum and saying, "Hey, if I put a candle in a microwave, can I make plasma?" Not knowing, and waiting for people to come back at me. And no, hey, do you think the flat Earth's real?
So but you still do it. You still choose to do it.
Sure.
And if you don't want to be right on this one, then why at times do you not accept, for example, my explanation? You don't. I don't because
the gravity wins and the vacuum wouldn't shred the Earth's atmosphere.
To be honest, Mark, I feel like you can probably make the same claim about us. But what I feel is that you're not trying hard enough to understand our explanations.
No. I disagree. I mean, you gotta remember, I've been doing this for 6 years now. I have heard the fact that you guys came up with some original questions. Kudos to you. I have not heard an original question in a long time, which is great. In this case, again, let's end it with this.
Sure.
I believe in the plot. I believe that writing should have a certain points to it, and they should be believable, and they've got to be easy enough to understand. And if they don't, for whatever reason, now if they're more complex, sometimes it just gets dull, and you're saying, well, if it's complex, it might be right. It's like, yeah, but the audience is missing it. If I part of my software training was was doing the proprietary stuff, was dumbing down really hard to understand time and attendance software to blue collar workers. That was my training. I taught people, it's like, okay, this horrible expensive thing, here's how you do it. And I got pretty good at it. So, but when I was doing this, I realized that these easier answers seem to make more sense, a lot more sense. Now, they went against a huge paradigm of science in that regard, but I was like, yeah, but it still makes more sense. I don't care. You know, again, the thing the reason why I keep doing it is that peer pressure really didn't mean anything to me. I didn't, have a body, colleagues, that you're worried about. Just like, oh, I know what happens when you get up to higher levels of academics. I wasn't worried about that. So I was like, look, if it makes sense, it makes sense to me. And the question is, does it resonate with anybody else? And put it out there, and it seemed to. I mean, come on, made the cover of what, Popular Science. It's not too bad. Even though they hated me, they still want to talk about it, which is great. And at least that the topic was introduced. I get very, very little hate mail, very few crank phone calls. Most of the time, it's just drunk people that saw the movie. So, anyway, thank you guys
Thank you.
for all this.
Thank you so much.
Hannah, do you
Yeah,
have
no
any-
worries at all. No, it was I am grateful to you for at least getting this far. Seriously, your friends can suck it because they should have
They
been here.
can, honestly.
They can
Trevor
because
and Gungeon.
well,
missed
I mean,
out.
but then again, that proves the point, which is like, look, it's so tough to get serious academics, which you guys are, uh, to even engage in it. And good for you that you did. I know that other people, I'm sure people are listening, probably going, oh my God, he's insane. But that's fine. It's we differ. I'm hoping the gap can be bridged one day. We'll see, one way or the
I
other.
hope so too.
But
Yeah.
until
Hannah,
then,
do you have any closing remarks?
yeah. The last one is if you want to know more about what I do, just type in Flat Earth Mark into Google. You'll find me. Don't take everything I say with a grain of salt. I'm not here to convince you. I'm not here to persuade you. I'm just here to give you an idea maybe you haven't thought about. But really, two other quick things: do your own research and ask questions. And honestly, if you think this is an interesting idea at all, and you think you got a good bead on life, don't look into it. Because and that's not reverse psychology. Seriously, it was like the opening of a book thing I wrote, which was like, don't, because once you go down a certain point, you can't come back from it. So that's the community.
Well, I guess, I mean, all I have to say is, I mean, thanks, Mark, for talking to us. I know that it might have been, I see why you might not be, willing to talk to the scientific community after, how they tend to treat people who believe in the flat earth. But as a scientist, I just think that I really believe that science is for everyone and that no one should be left behind. And I mean, not that I think you have been left behind, so to speak, but I really think that everyone, as a scientist, I feel like it's my job to talk to everyone, however crazy their beliefs might seem to me. And so I will always be willing to talk to
Well, cool.
you and people in your community, because as a scientist, that's what I've pledged to do. I've pledged to teach people what I want to know.
Would you be willing to, if you guys get good response from this, or if people say you shouldn't be giving them a platform, would you be willing to talk to another one of our guys?
For sure.
Down the road.
Sure.
I've got a guy.
Mm-hmm.
He wasn't in the documentary. He's very, very good. And I love him to death, and he's always looking for stuff like this. So
For sure.
if you guys are interested, I will shoot him your contact info and what he likes doing. He does a green screen behind him, and then just starts throwing up examples, bullet fast. So you're gonna have to be ready for that.
No, we will be.
Well, yeah, bring your friends.
Yeah. And I mean, if you ever want to, you know, I'll extend this to you as well. Like, if you ever are interested in learning some science or want to see what a physics department looks like, you know, I would be happy to show you, like,
Well,
up
thank
close and
you.
personal, like what it is to do science. And I hope that it can, like, we can learn from each other and maybe, yeah,
Well,
find
thank you.
find
That is
something in the
that is a
middle.
lovely offer. I don't know if I'll be allowed to do any international travel
Yeah,
soon,
that's the issue. That's the issue we
but
face right now.
In
But
the
we
future,
will
hopefully.
see. Canada seems to be an off-limit zone at the moment, but
yep.
we'll find out. But thank you guys very, very much. And if you need any other resources, feel free to shoot me a thing.
Thank you, Mark, for being here.
Yeah. Bye, guys.
Bye.
Bye. Okay, I'll stop
Well,
the record. Oh,
Hannah, do you have any thoughts now that he's not here?
I mean, I have a lot of thoughts.
I'll tell you one. That the takeaway for me, big time, is that, so before this, I was coming into this, I was thinking, what could be behind this mistrust in science and the growing skepticism around science? And I actually looked in. There's a researcher out in University of Amsterdam, I believe, where he looks into science skepticism, and a lot of people think that it's either political beliefs that are behind science skepticism, but that's not true. Turns out that the only bit of science that politics is a factor in is climate change denial. So tends to be, if you're more conservative, you don't believe in climate change science, sure, but that's the only thing. And what about religiosity? Okay, well, if you're more religious, it does, statistically, you tend to be a little bit more skeptical of science, but that is also quite a minor thing. So that doesn't explain the growing distrust in science. This researcher then went on to suggest that it could be that we are not explaining our concepts correctly, and it's an issue of science literacy. And that seems to be a reasonable conclusion. If you don't understand science well enough, then maybe you don't believe it. But even then, they show that that was not the case. Understanding of science has very little to zero impact on mistrust and science skepticism. The only area of science that it seems to have an effect on is GMO foods, whether you trust them or not. So what I was thinking coming into this is that there is no single cure to combat science skepticism, and we don't know what the cure is for this. So I was thinking that's why we need to have open conversations as scientists with these people, with these science deniers. And when you don't know the way forward, maybe it's best to sit down and have a conversation about where you're going. And I think the takeaway for me today was when Mark was saying that we want things to be easy. We want things to be easy rather than difficult to understand and difficult to digest. But why do things have to be easy? Maybe that's what's behind this denial of science. It's just a fundamental nature that as science gets more and more complicated, we want things to be digestible, but maybe they're just not. And maybe they don't have to be, and maybe that's what we should be thinking about.
I completely agree. Yeah, that really was off-putting to me when he said that, because it made me feel like what he was doing was just trying to sell the masses some easy way out to understanding their purpose in life. It made it sound like Flat Earth was really just like a religion that they were trying to, sell to people to make them feel at ease, like they could understand the world they live in. So that was off-putting. That was definitely a big takeaway for me. Another thing that was, I guess, upsetting to me was when he said that scientists were not willing to talk to him. Like, scientists were not willing to debate with him, ever. Or rarely. But I mean, that's not how we solve this problem. If people don't believe in science, the solution is not to alienate ourselves even more as scientists. That only confirms their belief that we are hiding something.
You only alienate people further. You push them further into their own beliefs.
And so I really, really believe, and I know not all scientists will agree with us on this, that I'm becoming a scientist not just to discover things for my own vanity or anything like that. Like I want to teach people science because it changed my life. And when I say teach people, I mean everyone. And whether you like it or not, science deniers are included in that everyone.
Absolutely.
And so we have maybe a duty or a responsibility to communicate science to the people who I think need it most. So
100% agree.
I understand if our peers don't agree with what we're doing, but I really think this is our best bet. That's all I'll say. Hannah. This is our best bet to get people to understand.
I'm with you on that. And on top of that, I think that moving forward, something that my opinion has changed after this interview is that we also have a responsibility to show that science by nature is not easy. It's not something that you're going to be able to digest just by watching a 5-minute YouTube video. The universe, Mark doesn't like that term, but the universe by nature is fundamentally complicated. And we are kidding ourselves if we're going to be able to understand it, being one person. So maybe we should be clear with that up front that, you know what? Things aren't easy to understand, and that's okay.
Yeah.
Well, I think we learned a lot today, and it was quite a long podcast, but I hope the viewers got a lot out of it as well.
Yeah, thanks for sticking with us if you're still listening. And we'll see you next week, hopefully with Gunjan and Trevor next time. And yeah.
Bye. Thanks for listening to our podcast this week. You can find us on YouTube, Beyond the Big Bang. You can also find our podcast channel on YouTube, Beyond the Big Bang Podcast, where we post clips from our podcast just like this week. And feel free to find us on Instagram and Twitter too. You know the handle, Beyond the Big Bang. We'll see you next week.